Hey, welcome to the Nanome Docking Advanced tutorial. So we're going to be covering how to run docking, how to look through docking results, and what that might mean. So I went ahead and imported a protein here. It's 5CEO on the protein databank. And if we zoom in, we actually have a ligand that sits really nicely in this binding pocket. And what we want to do first is differentiate this ligand from the rest of the protein. So we use the selector tool. We're going to select that, and then we're going to want to split it out. So right here, we just click split. This now means that it's a sort of independent molecule. If we unlock it, we could take it out there, and then if we sort of moved it around and you wanted to get it back, we could just realign it with this alignment tool. Cool. So those are aligned. That's looking good. Now we're going to go ahead and pull up the Smina docking through Stacks. So you click on Stacks if you are Stack enabled. Not everybody is Stack enabled, but Stacks does allow you to do compute in the cloud, such as Smina docking. We click on Activate. And now what we have here is a nice little docking menu. So we're going to choose our ligand. For us, the ligand is going to be 5CEO 1-A. And so we click 5CEO 1-A. Our receptor is going to be our protein that we want. And so for that, we just click on 5CEO1 in this case. And then the docking site is going to be, in this one, it's going to be the same as the ligand. And so we click 5CEO1A. If we wanted to increase the size of the bounding box, just imagine there's like a box around this ligand that's like the search space where it's trying to dock. If we wanted to increase that, we could do it manually by entering here, or we could also scroll left and right with this angstrom size. So I'll just leave it around 6. I think that sounds good. And lastly, this is our number of poses. So we only have one ligand that we're trying to dock, and let's go ahead and generate 7 different poses. So this is going to take a second after I run dock. And so what it's doing is it's taking this ligand, and then it's looking in this location, and it's looking at all the ways this ligand could fit in there. So it's saying, oh, what if it was flipped around? What if it was like that? What if it was like that? Maybe it could be sort of on the outside of the pocket. And now what it's done is it's given me all those results back here. So let's go ahead and look at them. It hid the initial ligand, so we could see if we want to do a comparison. This is where the original ligand was, and this is the new ligand. They're very close to each other. So let's just hide the original. And now we're going to click on this nice little play button stack of disks, and that's going to open up the docking menu for this file. And what's cool about this is that it'll actually show you all 7 of those results here. You just need to play through them. And there's various ways you could do that. You could click this little next arrow to go next, next, next. And you could see every time we click that, it scrolls through a new molecule there. Or what we could do is we could grab this dial with our index finger, and then you could scroll through by just rotating your wrist. Or we could also set it to autoplay. And when we do that, this loop is just going to go all the way to 7 and then all the way back to 1. And right now we're playing at a 5x speed. You could do this a little bit slower for this case, maybe at a 1x speed. Kind of get an idea of how that molecule is docking in there, where it's sitting, what the score is, and give you a good idea for maybe some changes you might want to make. And of course, if you did want to use the medchem tool as well, you could freeze any of these frames, use the medchem tool, make a modification, if you wanted to add a nitro somewhere on the molecule. If you did that, you would now have a new molecule, and you could go ahead and redock that with Smina as well. But yeah, now that you understand the basics of how to select a molecule, how to boot up Smina docking, how to look through the results, let's go ahead and check out the ranking system. So for this, we're going to have this edit and metadata tab. So on metadata here, we could do this ranking. And so right now, I'm going to take my number 1 result, and I'm going to go ahead and give that a 5-star ranking. I thought it was really good. It was pretty much right where the original ligand was. Deserves 5 stars in my playbook. The next one, though, number 2, looks pretty similar. Maybe that's a 4-star. Number 3, 3-star. Number 4, yeah, maybe that's a 2-star. Number 5, maybe I like this one. This one's a 4-star again. Number 6, let's give that a 3-star. And number 7, I don't think I like this pose at all. That's a 1-star. So, it's kind of arbitrary what stars you give them, but what that allows us to do is allows us to look at our rankings here and actually sort by ranking, so we could see sort of which ones are performing better than others, or which ones are worse. So we have our 1-star and our 5-star, or you could reverse it, and now at the top we have our 5-star, and at the bottom we have our 1-star. So yeah, that'll go ahead and sort it. This will select all of them, so if we wanted to select all of them for some reason. And additionally, in this metadata tab, each one of these is going to have different scores. So you could scroll through, look at them, look at each one of the minimized affinity. See, this minimized affinity is the one that we want. And that'll go ahead and just list them all out in a sheet here so we can see. And you can see that the top -9.6, then -9.5, all the way down to our least score, or the highest score, I guess, but our least desirable score here with -8. Yeah, Sam, did you want to share anything else about docking here?
Yeah, I think it's always important to remember that docking will tell you the lowest energy minimization of the small molecule within a specific pocket, but it may not reflect like its actual binding affinity. So typically in computational chemistry, we also have additional methods to score how well that small molecule actually predominantly binds. But this gives you a really good understanding of the poses that it's going to take inside of a pocket. It's really great for ideation, especially alongside like that real-time design mechanism that we had with the MedChem tool. So overall, looks great. Good job, Steve.
Cool, awesome. Well, yeah, thanks Sam for joining, and I hope this has been helpful for you. And please enjoy the rest of our advanced tutorial series, or maybe you're gonna make your own spatial recording to let the rest of the community know what type of things you enjoy in Nanome. So thank you.